Hi everyone, good morning. Welcome back. Can you see my screen, everyone? Can you confirm? Am I audible? Yeah, fine. So in the last session, we discussed about SDLC, right? Software Development Lifecycle. Software Development Lifecycle, right? So every organization they use, they are using SDLC because currently most of the project teams they are using Agile methodology. What is Agile? Anyone? What is Agile? It's a parallel development, right? So earlier we used to use waterfall methodology, which is sequential development, right? So currently, most of the project teams are using Agile methodology. In Agile, we are creating sprints. What is sprint, anyone? What is sprint? Sprint is nothing but
Time timeline.
it's a timeline, right? So sprint can be 1 week to 1 month, right? So once 1 week sprint, for example, one sprint start today. So by next Monday EOD that should be completed, which is a 1 week sprint, right? And 1 month sprint. So for example, 30th Jan, one sprint started today. By next month ending, that should be completed, right? So based on the requirement, so sprint is nothing but timeline, right? Yeah. So before that, we discussed about DevOps introduction, question and answers, and also cloud introduction. So we have completed 4 sessions, right? So 4 sessions are introductions only. Introductions only, right? So anyone newly joined today? Anyone newly joined today? Can you share your WhatsApp number, email address in the chat? So my mobile number already shared with you, everyone, right? So my mobile number is 96422111711. So is my number, is my personal number. Trainers, they never share their personal numbers, right? Yeah. So from Harsha Trainings, we share our numbers. Yeah. So Nakul, can you share your WhatsApp number and email address in the chat so that we'll provide you? Take down my number. Everyone, take down my number. So this is my mobile number. You can take down. So if you need any additional information, you can reach out to me. You can call me, you can WhatsApp me after this session so that we'll discuss. So anyone newly joined today, can you share your WhatsApp number, email address in the chat so that we'll provide you all the recordings, previous demo recordings and the course content. My mobile number is 96422 You can take down my number. You can WhatsApp me, you can call me after this session if you need any additional information. Fine. Yeah. So today we are going to discuss about servers and networks. Introduction to servers and networks. Right. So before going to cloud, first we need to understand this basics. These basics are very important. So this terminology is very important. Right. So if you understand these basics, you can easily understand cloud environment, cloud infrastructure, AWS infrastructure, right? First, we are once complete this basics, then we'll start AWS, right? First, we'll work on AWS. After that, DevOps. After that, Azure. After that, Google Cloud. So this is multi-cloud with DevOps course, right? Multi-cloud with DevOps. AWS, Azure, Google Cloud. 3 clouds will be covered, and DevOps also will be covered. Linux also will be covered, right? So why we require 3 clouds? So because every project team, every organization, they're using at least 2 cloud platforms, right? So if you learn 3 platforms, you can cope up in any project. You can crack any interview. Fine. Yeah. Let's get started. Fine. So today's agenda here is what is server, types of servers, server client model, best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, subnet, gateway, router, firewall, failover, load balancer, right? So these are all very important. So today we discuss up to here only. This will take 1 hour. Up to here you can cover today. So tomorrow we are going to work on networks. Okay. Yeah. What is server? What is server, anyone? What is server? Server ante enti? Anyone having idea? What is server? Server is a computer, right? Server is a computer. So server is having high computing power. Server is having high computing power, right? Yeah. So this is the definition. See here. A server is a computer that serves information to other computers called clients, right? So normally in real-time projects, every developer, every tester, every DevOps engineer, they connect servers. They store the data on servers, right? They connect servers through either LAN network or WAN network or Wi-Fi, right? So why we require servers here? What is the importance of servers, right? So servers we can centrally configure. We configure in data centers, right? Server room. Servers we can configure in server room, right? So the servers are having high computing power, like high CPU, high memory, high storage, like 48 GB RAM. So quad core CPU and storage 10 TB storage. So like that high computing power is having with the servers, right? So every developer, every tester, every DevOps engineer connect to the servers. Developers always store the data in server side only. They don't store the data in laptop or desktop, right? So laptop and desktop is having only one storage, one CPU, one memory module, right? But server side, we are having so multiple RAM modules, multiple storage drives, multiple processors. In case one storage drive is corrupted or crash, so server will not be down anywhere. Server will not be down, right? Server will run without any issues. Okay. If any memory module is corrupted in server, right? So nothing will be happened. Server will run normally, right? But whereas laptop or desktop, in case RAM is down, RAM is fail, RAM model is fail, what will happen? Completely OS will be down, system will be down, right? But whereas server, multiple storages are multiple storages, multiple RAM modules, multiple processors will be available. So that is why servers will not be down, right? Yeah, in case one drive is down, nothing will, no data will be lost, right? Yeah, that is why. So this server centrally we configure in data centers, server rooms, right? A server is a computer that serves information to other computers called clients. What is client? Client is nothing but either desktop or laptop. So yeah, so can connect to a server through either a local area network or wide area network such as the internet. This clients can connect a server through either LAN or any other network, wide area network or Wi-Fi, right? So to serve the to access the data from servers. Clear, right? Types of servers. What are the types available? So these are the three important types of servers, right? First one is a blade server. Blade server. So this is thin server, this is thin server, modular server, small module, right? This is a rack server. Rack server is nothing but it is a traditional server. Traditional. So currently most of the data centers we are using rack servers only. So we can, yeah, we can configure rack. Inside of the rack we can insert server. So this is the server. So backend we can connect power network, right? We can install operating system, applications and patches, plugins. Then we can move to production, right? So this is a tower server. it is a it is a oldest server. Let us go with one by one. See here, blade server. A blade server is a modular server that allows multiple servers to be hosted in a smaller area. So this is one container. Instead of the container we can insert blade servers like this, right? Yeah. So these servers are physically thin and typically only have CPU, memory, integrated network controllers. So these servers are thin. These servers normally we can configure in large data centers, large, like Google data center, USG, right? Verizon, AT&T, right? So this type of large data centers we can configure this. Facebook, Twitter. So they have data centers, large data centers. In large data centers we can configure the blade servers, right? Yeah, so these servers are having only CPU, memory, integrated network controllers, and sometimes storage drives also inbuilt. So here without storage, how can we work, how can we configure the servers here? These servers are physically thin, typically have only CPU memory integrated network controllers. Without storage, how can we store the data? Sometimes storage drive is inbuilt, but if the storage drive is not available inside of this, how can we install operating system? How can we configure? So because external storage we can attach to the blade servers. So blade servers are often seen in large data centers like Google data center, Microsoft, like Amazon, right? This type of data centers we can use this blade servers. Next one is a rack server. A rack server is a server mounted inside of a rack. Rack servers are typically general purpose servers that support a broad range of applications and computing. So these are the rack servers. These are the traditional servers. Most of the data centers we are using currently, right? Next one is a towered server. A towered server is a computer that is built in an upright cabinet that's standalone and that is designed to function as a server. This is the towered server. Bit vault server, right? So these are the common servers which we can configure in data centers normally. So physical servers we no need to worry about currently, right? Because we are using cloud infrastructure, right? So these are traditional servers. So in local server room we used to configure this. Fine. So currently most of the project teams they are migrating their applications to cloud servers, cloud infrastructure. Fine. Next one is the client server model. See here. So this is the server. This server we can access through network from either laptop or desktop. When we send request, immediately server will give response. Right? We can access the data from server. We can store the data into server. We can access through network, any network, local network, LAN connectivity or WAN connectivity or Wi-Fi, whatever network we have. Fine. See here. So this is another model, server client model. So this is the desktop, laptop. We can use a tab also to connect our servers through internet, right? Yeah. Next one, server architecture. So this is very, very important, right? So what is server architecture? So server architecture is the foundational layout or model of the server. So based on which a server created and are deployed. So it defines how server is designed. Okay. Now let's try to understand few important things here. Yeah. Server architecture. Server architecture. Initial phase of implementation. Initial phase of implementation. Initial phase. So initially, how server architecture designed. Okay. So this we can say first phase. First phase. In 1990s and early 2000, in 1990s and early 2000, how the server architecture, how the project teams used to configure the servers, right? Let's try to understand. This is very, very important. In 1990s and early 2000, how was the server architecture, right? So for example, we have four applications are there, like Java, Python, right? And C++, and also Tomcat. For example, four applications are there. Okay. So in 1990s and early 2000, project teams used to take for one application one server. They used to take for one application one server. Here we have four applications are there. So project teams used to take four servers for four applications. Okay. For example, so these are the servers. So four servers I'm taking here for four applications. In 1990s and early 2000, highest capacity of the storage is 1 GB. 1 GB storage is the highest capacity by the time. 1 GB storage is highest capacity of the storage. These are all 1 GB storage servers. Okay. Yeah. Fine. So one server, one application. By the time one application we used to deploy onto one server. For example, I deployed Java on this server. So Java will take, for example, 300 MB. For example, I'm saying, okay. So remaining space will be wasted, right? So 300 MB occupied by Java in the server. So here 700 MB will be wasted, right? Yeah. So Python occupied, for example, 350 MB, 350 MB. So remaining space will be wasted. 650 MB space will be wasted here. Right. Next one. So C++. Occupied. So 400 MB, for example. So remaining space will be 600 MB space will be wasted here. Next one, Tomcat. Tomcat is web server, right? So this will occupy, for example, 450 MB. So remaining space 550 MB will be wasted, right? So earlier in 1990s and early 2000, project teams used to take like this. Every organization they used to configure like this. Okay, yeah. So here, what will happen? What is happening here? Less utilization, more costing. So in 1990s and early 2000, hardware costing it was, yeah. So by the time project teams used to spend more billing for hardware purchases, right? They used to buy servers with heavy costing. So by the time even desktop laptops also too much costing, right? Yeah. So here less utilization, more costing. That is why project teams used to spend more budget for this. That is why so they used to get so many burden. They used to yeah, normally hardware costing should be less, right? Because yeah, every project team they try to cut the costing, every client, right? But here hardware costing is higher, less utilization. That is why so this concept is failed concept. This concept is failed. This model is failed. Initial phase of implementation is failed. Yeah, slowly in second phase of implementation, what happened? In second phase of implementation after 2000, second phase of implementation. In second phase of implementation, what happened here? So the project teams used to take one higher capacity server like this. One higher capacity server. They used to deploy all the packages in only one server. This is second phase of implementation. So they used to deploy all the all the applications like Java, Python, C++, and Tomcat. They used to deploy all the applications on higher capacity server. Yeah. So for example, we have four users are there. Four users. So Java user may access Java application. Python user may access Python application. C++ user may access so respective application. Tomcat user may access Tomcat application. Right. So four users are accessing same server. Here what will happen? Here one drawback is, yeah, so Java user may access Python application also, right? So there may be chances to access. Python user may access so this application. Yeah, C++ user may access Tomcat application. So there may be chances to access other applications also. So because all the users are accessing same server, security will be there, but there may be chances to access other applications also, right? For example, four people are staying in 2 BHK flat. So two guys are staying in one bedroom, other two guys are staying other bedroom. So the four guys can access commonly kitchen and dining, right? The same way, The same way, 4 guys are accessing server, they can access other application also. There may be chances to access, right? That is one drawback. And one more drawback here is, so if the server is crash, what will happen? The server is crash, what will happen? All the applications will be gone. This is also one of the drawback. That is why this model also failed. Second phase of implementation also failed. So this is also failed concept. Okay. Yeah. So yeah, in third phase of implementation, slowly, in third phase of implementation, what happened? In third phase of implementation, what happened here? So virtual servers. We started using virtual servers. Okay. Like virtualization. Right. So what is virtualization? What is virtual server? Anyone? Anyone having idea? What is virtual server? Yeah, virtual server is nothing but which is not physical, which is imaginary server. Imaginary server. Virtual server is nothing but it is not physical. It is a imaginary server, right? Yeah. So the functionality is same. Virtual, physical functionality is same, right? Yeah. So virtualization. So here what happened? This is base OS. This is base operating system. We can say this is base OS. Physical server, I can say physical server, base operating system, right? So we take one physical server which is high end capacity server. For example, so in this server we have RAM 48 GB, high end capacity server, CPU 32 core, and storage hard drive HDD or SSD. We can use here 10 TB, like this high-end capacity server we can take. So on top of this we deploy one software which we can say VMware or hypervisor, Hyper-V or Citrix. These are all virtual softwares. These are all virtual softwares, right? So what we are doing here, we take one physical server. On top of this we deploy one software which is either VMware or hypervisor or Citrix. So this software will allow you to create virtual servers, right? Yeah, so this software will allow you to create virtual servers. So on top of this, what we will do, we can create virtual server, virtual servers, right? So here, these are all virtual servers. So based on the physical server capacity, we can create virtual servers like this. Okay, so here, these are all virtual servers. Now, so this is one virtual server. These are all the virtual servers. 25 servers, 5 into 5, right? So here we can deploy different operating systems like Windows, Windows 2022, base Windows OS, and here we can deploy Linux operating system which is RHCL. Here we can deploy Linux operating system CentOS. Here we can deploy Ubuntu Linux operating system. Here we can deploy Windows 2016 data center version, right? So like this, whatever operating system you want to install, you can install on this virtual servers, right? So we have 25 servers are available here. So these servers utilize hardware from which server? This virtual servers take the hardware from where it will take this physical server. Physical server hardware, those virtual servers will be utilized. Currently, we are using even the cloud servers also virtual servers, not physical servers. So we are creating AWS servers, right? Currently, we are using AWS servers here, right? So if you click on this, see here, these are the AWS servers. These are all virtual servers. So instead of the AWS data center, we are creating virtual servers. So backend hardware should be required, right? But that hardware is available somewhere. In that, we are creating virtual servers, imaginary servers, right? Fine. So these servers take the hardware from base OS. Okay. Yeah. So whatever operating system you want to install, you can install. Whatever applications you want to install, you can install, and we can access these servers, right? Yeah. So here also some drawbacks are there in virtualization. Also some drawbacks are there. So for example, if you want to install operating system OS, right? So we use ISO image. ISO image. What is ISO image? ISO full form is International Standardization Organization. So this is the full blowing operating system, full package of the software. To install operating system, we use the ISO image. For example, in your laptop, if you want to install Windows, how can we install? We require one software, right? We require one image. That image we can copy into pen drive, so we can connect to our laptop. We can boot as a bootable drive. So by using that pen drive, by using that bootable drive, we can install our operating system in our laptop. Same way, so in virtualization also we required ISO image to install operating system. This ISO image minimum size would be 6 GB to 18 GB. So this ISO image size minimum 6 GB to 18 GB. For example, if you take Windows 2022 operating system, we require minimum 17 GB OS size, OS image size, right? RHCL 10 GB, CentOS 7 GB, Ubuntu 6 GB, like that. So as per the requirement, we can utilize the ISO image size. So yeah, on an average, for example, we have 25 servers, right? 5 into 5. So on an average, every server will take 10 GB, for example. 10 into, yeah. So 10 into 25, right? So yeah, only for operating system we use 250 GB, only for operating system. On top of that, again we need to install Java, Git, Maven, Python, C++, right? Patches, plugins, everything we need to install. So the server will take more space, right? So storage costing is very higher currently, right? Yeah. So only operating system we are spending 250 GB. On top of that, we need to deploy all the applications, right? So this is a one small drawback. And also, so when we restart any server, when we restart or reboot, both are same. Restart or reboot server, this server will take minimum 4 to 8 minutes. So server normally takes 4 to 8 minutes. So laptop we can restart immediately, but server side, when you restart, it will check processor, updates, everything it will check and restart slowly, right? So why we require restart? Because when we deploy any packages, when we have any maintenance activity, we need to restart the servers. So if the server is taking 4 to 8 minutes, what will happen? Business will be impacted. For example, one of the server Flipkart is running. For example, if you restart the Flipkart server, it takes 4 to 8 minutes. What will happen? Business will be impacted, right? So Flipkart business will be impacted. That is one drawback. And also, and also deployment time and downtime is high. What is deployment time? Anyone? What is deployment time and what is downtime? Anyone? Yeah. So when you want to deploy any applications or when you want to deploy any coding, when you want to deploy any war files, jar files, right? It takes more time. So when you want to down the server, it takes more time. So downtime, what is downtime anyone? It is a maintenance time. Maintenance time, right? So when you want to deploy any packages, when you want to deploy any application, it takes more time. And when you want to down, when you want to restart, when you want to down, takes more time. So these are all drawbacks available in virtualization. So still we are using virtual servers, VMware servers, hypervisor servers, Citrix servers. But these are all drawbacks are available here in the virtualization. This is third phase of implementation. Okay. Yeah. Next one, important one, which is very trendy. So currently we are using, so which is fourth phase of implementation, which is Docker containers. Currently we are using Docker containers. This is a, yeah, advanced one. Currently we are using latest one, right? Yeah. So every project team, every organization, every team members, they are hosting their applications on Docker, right? So Docker is very advanced tool. So currently most of the project teams are using Docker, right? Now let's try to understand Docker architecture. Same as virtualization, we can take one server, which is, we can say, AWS server, for example. This is AWS EC2 instance. This terminology is very, very important. So in AWS server we can call it as EC2 instance. EC2 full form is Elastic Compute Cloud. Okay. So this will be repeated. So while working on AWS, I'll repeat it again. Okay. Yeah. EC2 full form is Elastic Compute Cloud. EC2 instance server, we can call it as EC2 instance. Okay. So this is AWS server or Azure server or Google Cloud server, any server. Okay. So on top of this, what we will do, we deploy one software, which is, we can say, Docker image. Docker image. Okay. So this will allow you to create Docker containers. This will allow you to create Docker containers. So these are the Docker containers. Okay. Yeah. So in this containers, we can deploy required operating environment. So here I can deploy, so Windows 2023 also available currently. Okay, 2023 operating environment also available. So here I can deploy RHCL, Red Hat Enterprise Linux, which is a Linux operating system. Here I can deploy Ubuntu Linux operating system. Here I can deploy even Mac OS also. Even Mac OS also you can deploy here. Whatever operating environment required. Okay, we can deploy. Fine. So here, when we run the container on Docker, only lib and bin files will be installed. Only lib and bin, library and binary files will be available in the Docker container. So Docker infrastructure, so Docker containers are very lightweight. So what is Docker? So basically, what is Docker? Docker is a container tool. Docker is a container tool. What is container?
It is a storage device.
Yeah. So in general, container is just like box. Container, just like box. That box we can move anywhere, we can use anywhere. It is a lightweight standalone, right? So it is advanced to virtual servers. Docker is advanced to virtual servers, right? Yeah. So when you want to deploy operating system here, this will take 200 MB only. For OS, this will take 200 MB. So very lightweight. Here, how much it is taking here? 6 GB to 18 GB for only operating system, one server. But one container, it will take 200 MB only in the Docker container, Docker, right? And also, when you want to restart or reboot, this will take 15 seconds only. When you want to restart container, this will take 15 seconds. So even though the developer who is working on the container, they will not understand whether it is rebooted or not. So it's very faster. Docker containers are very faster. So when you restart, it will be restarted immediately. So very quickly. So currently, we're using online shopping, digital applications, right? So Mintra, Meesho, Trends, right? And Flipkart, Amazon shopping site, right? So these are all digital applications. So when we book any product, that will be delivered very soon. Recently, I booked one mobile online, right? So they deliver within 4 hours. How can they deliver within 4 hours? Because backend they have containers, Docker containers. Okay. So recently, few weeks back, I booked one mobile. So one plus latest mobile. So they deliver within 4 hours only, right? Yeah. And also here, deployment time and downtime is very less, right? So when you want to deploy applications on Docker, so it's very faster. Quickly we can deploy. When you want to restart, quickly it will be restarted. So moreover, one important feature is there here. One important advantage is there. So it is a cost effective. Cost licensing cost is very less in Docker. So whereas here, so if you want to install Windows or RHCL or CentOS or any operating system, we need to buy the licensing first. So before installing operating system, first we need to install license. We need to get the license. That is higher costing. But Docker licensing is very less costing compared with the normal OS. So that is why every project team they are looking for Docker containers. So client always look for the cost saving, right? That is why. So here Docker is very popular now. So most of the project teams they are using Docker. Okay. So while working on Docker, we'll go deep dive. So Docker will take nearly 8 sessions. 8 sessions. Okay. Eight to
Docker is like a database.
Docker is a container tool. So currently we are using virtual servers, right? Virtualization. Even virtualization also we are using currently. Docker is advanced virtual servers. So for example, if you want to work on any application, if you want to deploy any application, we work on servers, we deploy on servers, right? In place of virtual servers, we deploy onto Docker containers. So, yeah, Docker containers are advanced to virtual servers, very faster, quickly it will run. For example, Flipkart is deployed on one server, right? So server is a bit slow compared with containers. So currently, Flipkart, Amazon shopping site, Myntra, Meesho, Trends, they migrated to Docker containers. They deployed onto Docker containers. So it's very faster. You understanding, right, everyone? Everyone following, right? Non-IT guys, freshers. Docker containers are advanced to virtual servers. Yeah, how many containers we can made on Docker? So we'll see that. We'll see that. I'll show you. So one, yeah, we'll go deep dive. Don't worry. So wait for some time. Okay. For example, yeah, I just want to show you some difference here between virtual servers or physical servers and Docker containers. Okay. Yeah. So what we are saying here, Docker containers are very lightweight, standalone. We can move anywhere. We can use anywhere. Right. Yeah. Fine. So the example here is one of my friend is working with Wipro. Is also architect. Okay. So he moved from Hyderabad to Manali, Himachal Pradesh. He's staying in Manali since long, since 3 years. He's working from home. He's having a permanent work from home. He's not going to office, right? So he's working from Manali. He's based out of Hyderabad only, right? He moved to Manali. So with his family, okay? So he can move to anywhere from Manali to Kashmir, Shimla. He can move to anywhere. So because lightweight, right? Very less resources. You can have. See, in Hyderabad is having home. He's having father, mother here. He's having other properties here. But he moved to other place. From there, he can move anywhere. But whoever established here already, they cannot move immediately. That is uh, that is full blowing. Lightweight means just like container. That person is having one kid. Okay, he can move anywhere simply. Limited resource, limited items he is having. And one more thing, for example, yeah. So wife and husband and two kids. They want to stay normal living. What they required? Major things. Mainly what they required: food, bed, clothes, normal living, right? And if they want to stay, if they want to live lavish, what they require? Furnishing, AC, right? Yeah, they required more thing. Many things are there, right? Yeah. So this is Docker is lightweight, normal living. Virtualization is lavish. Both are functionality by same. Both are functionality by same. But if you want to deploy war file or jar file or ER file, so either we can use lib and bin files, lightweight environment, or else full blowing. So our requirement here is we need to deploy war files or jar files. So whatever code development developers, that should be deployed onto respective environment. To deploy war file or jar file, we required only lib and bin files. We don't require full blowing operating system here. Understanding right, everyone? Right? Yeah. So yesterday we discussed in the SDLC deployments we discussed, right? So developer develop the code in their local workspace. Once development is completed, they push the code to GitHub. Once they push the code to GitHub, from there Jenkins will take and deploy onto respective servers, right? The same way, yeah, here, so this is a lightweight environment, lightweight. To deploy war files or jar files, we require only library binary files. We don't require all the features. So in virtual servers or physical servers, so when we install operating system, what will happen? Paintbrush will be there, media player will be there, drivers will be there, right? And the patches will be there. These are all available. But whereas containers, only library binary. To deploy war file, library binary is enough. So it occupies only 200 MB. So when we run the container, only 200 MB. But here 6 GB to 18 GB, right? Yeah. So this Docker launched in 2013. Docker released in 2013. Okay. Yeah. So immediately after one year in 2014, Kubernetes released. Kubernetes. Kubernetes is advanced Docker. So without Docker, Kubernetes will not work. Kubernetes is having some dependency. Kubernetes is having some dependency. Instead of the Kubernetes, Docker contains required. Understanding right, everyone? Yeah. So before Docker also we used to use some containers. Before Docker, what are the containers we used to use? Before Docker. Also we have containers. Okay. What are those? LXC, one of the container. Jones, LMCIFI. So these are all old containers. LXC, Jones, LMCIFI. LXC is a Linux container. Linux container. Jones is a Solaris container. LMCIFI, which is a Google container. LMCIFI full form here is let me container for you. Let me container for you. Full form. So before Docker, we used to use LXC, Jones, LMCIFI. These are the oldest containers, right? So these are all platform dependent containers. What is platform dependent? Anyone having idea? So these are all platform dependent containers. What is platform dependent? Anyone? Anyone having idea? Yeah. So platform dependent containers. What is platform dependent? Anyone? These are all platform dependent. So yeah, see here. LXC, Linux container will run on only Linux operating system. Jones will run on only Solaris. LMCI FI will run on only Google. So the respective platform, it will run on only that respective platform. That is why these containers are failed. These containers are failed, right? So currently we are using Docker. Currently we are using Docker, right? Yeah. So Docker is a platform independent. Currently we are using Docker. Docker is the platform independent. Docker is the it is a platform independent. So what is platform independent? Anyone? What is platform independent? Irrespective of operating system, we can run Docker containers on Windows, Linux, Solaris, even though we can run on Mac OS also. Mac OS also. So irrespective of operating system, we can run on any platform. That is why so Docker is very popular now. Docker is very popular now. So currently most of the organizations they are using Docker. So before Docker we used to use these old containers. These are all platform dependent. It will depend on respective platform. But here so Docker is we can run Docker containers on any platform. It is a platform independent, right? So while working on Docker, we'll go deep dive. We'll go very deep dive. Clear it, everyone? Any questions up to here, anyone? Any questions, any doubt out? Any doubts up to here? Anyone having any questions here before going to next concept? You can ask me if you have any questions. Yeah, we can install in physical server also, but currently we are using cloud environment, cloud infrastructure. Someone asking what is library lib and bin. Lib and bin means system files only. System files only. Lib library binary files required files to deploy war file jar file. Lib bin required. How many containers can be created on Docker? So we have some count. I'll show you how many containers we can create. How many pods we can create. I'll show you. Okay. Yeah. So on Docker server supports. I explain. I'll show you. If I explain right away, you'll be confused. Okay. Wait for some time. So while working on Docker, we'll go deep dive. Okay. So base OS system will be used by yes, base OS only. Yes, correct. Clear right up to here, everyone? Clear right? Yeah. Fine. So while working on Docker, we'll go deep dive. Docker will take 8 to 9, nearly 9 sessions, nearly. Okay. Yeah. Docker networking, Docker concepts, so many concepts are there in Docker. Okay. We'll go deep dive. Fine. Yeah. So we are discussing about server architecture here. So this is the server architecture. While working on networking part, we'll show you networking and server architecture. I'll show you this. Okay. Next one. What is operating system? What is operating system? Anyone? What is operating system? So we discussed about operating system here, right? OS, operating system, image, ISO image. This is OS. What is operating system? What is operating system? Anyone having idea? Real time, guys. Yeah. So every computer, like server, laptop, desktop, hardware understand only binary language. Binary language. What is binary language? Zeros and ones, right? So 0000001 100 111 like that, right? So hardware always understand the binary language, but a human user will not understand binary language. That is why we required one translator, which is nothing but operating system. So operating system is an interface between user and the computer hardware, right? Yeah, so this is the definition. See here. So operating system is an interface between user and the computer hardware. The hardware of the computer cannot understand the human readable language as it works on binaries, that is zeros and ones. In such case, we need an interface which can translate human language to hardware and vice versa for effective communication. Hardware to readable language, human readable language to hardware. Translation will be happened by the operating system, right? So operating system will translate from hardware to human readable to hardware. Fine. See here. So in between the hardware and end user, we have operating system. These are the operating system types. Fine. Next one, types of operating systems. What are the types available? Single user, single tasking operating system. So in this type of operating system, only one user can log into the system. He can perform only one task at a time, which is nothing but MS-DOS. In Microsoft data operating system, only one user can log into the system. He can perform only one task at a time, which is nothing but single user, single tasking operating system, right? Second one here is single user multitasking operating system. So in this type of operating system, multiple users can log into the system. They can perform, sorry, single user, one user can log into the system. He can perform multiple tasks at a time. Single user multitasking. One user can log into the system. He can perform multiple tasks. For example, Windows. So while working on Windows, while working on any activity, we can run background audios, right? We can run background audios. For example, you are working on paintbrush. You can run background audios, right? So which is nothing but single user multitasking operating system. Next one is multi-user multitasking operating system. Multiple users can log into the system. They can perform multiple tasks at a time, which is nothing but multi-user multitasking operating system. So which is nothing but Linux and Unix. So while working on deployments in real-time projects, while working on deployments, right? Yeah. So developers will log into the systems servers, testers will log into the servers, even DevOps engineers also log into the servers. They can perform their own activities, right? So while working on deployments, code deployments. So normally we are working on Agile methodology, right? In Agile, once sprint is completed, the sprint should be deployed onto respective servers, respective containers. By the time developers log into the servers, containers, testers log into the servers containers, DevOps engineers also log into the servers and containers. Linux allow you to log in. Linux allow number of users Linux allow to log in, right? So currently most of the organizations, most of the project teams, they are using Linux operating system only, right? So even Windows also using, but most of the servers Linux only. So even Linux also will be covered in our sessions. Once to start the AWS services, after few sessions, Linux also will be covered. Clear, right? Up to here, clear, right, everyone? Yeah. Networking part we'll see tomorrow. Networking part we'll see tomorrow. Okay. Any questions so far, anyone? Any questions, anyone? So new guys, whoever joined today, I'll provide you previous recordings, demo recordings. Okay. So you can take down my number. My number already shared with you here, 96422111711. Can you share your number newly joined today? Whoever joined today, new guys, whoever joined today, can you share your WhatsApp number? So email address in the chat so that we'll provide you previous recordings. Or else you can ping me, you can WhatsApp me. I'll provide you previous demo recordings. Okay. Yeah. So tomorrow we are going to work on the networking part. So after that, day after tomorrow, we are going to start AWS. Okay. From Thursday onwards, we are going to start AWS. Okay. So from Thursday onwards, everyone should use the laptop. Everyone should prepare your laptop to practice. Okay. From first Feb, AWS will be started. Fine. So tomorrow we are going to complete this networking part. So networking part also very important. So types of networks, different types of networks are there, right? So different types of see here, different types of networks, LAN, WAN, MAN, right? So these are all very important. So why we are discussing this networking and servers? Because before going to AWS, we need to understand this basics. If you understand this basics, you can easily cope up in the AWS. Fine. Yeah. So we can wind up here. So the people who are not added into WhatsApp group, we can add today itself. Okay. So link will be changed because we are going to start AWS very soon. Link will be changed. Okay. You can add into WhatsApp group as soon as possible so that you'll get all the information in the group only. Fine. We already allowed 5 sessions. Today is the 5th session, right? So you can add into WhatsApp group as soon as possible. Once you make the fee, you can share the screenshot to me so that I'll add into WhatsApp group. Fine. Yeah, we can wind up here. Fine. Thank you all.